In this lesson, we begin solving logarithmic equations. The steps for solving a logarithmic equation. First of all, isolate the logarithmic function. Second, part A, if convenient, express both sides as logs with the same base and equate the arguments of the log functions. We'll skip part B for now and go on to step 3, which is to check that solutions are in the domain. Let's solve the following equation analytically. Log of 2x plus 3 equals log of 5 minus x. Note that the log on each side of the equation is isolated. I can use the one-to-one properties of logarithms to set 2x plus 3 equal to 5 minus x. And I'll then solve for x by adding x to each side. I'll have 3x equals 2 or x equals 2/3. I need to check that 2/3 is in the domain of each of these logarithmic functions. Let's look at what the domain is. For log of 2x plus 3, we must have 2x plus 3 be greater than 0, which means that x will need to be greater than -3/2. That works. Let's check the domain of the log of 5 minus x. Here 5 minus x would need to be greater than 0, which means that -x will be greater than -5, and then that x will be less than 5. Well, 2/3 is less than 5, so 2/3 is a solution here. We'll move on to solving the equation. The natural log of x squared minus 15 equals the natural log of x minus 3. Again, the natural log is isolated on each side of the equation, so we can go ahead and use one-to-one properties of logarithms to set x squared minus 15 equal to x minus 3. I want to get a 0 on the right-hand side of my equation here, so I'll subtract x, add 3. That gives me x squared minus x minus 12 equals 0, factoring into x minus 4 times x plus 3. Then setting each factor equal to 0, we'll have x equals 4 and x equals -3. I need to check that these solutions are in the domain of my logarithmic functions, natural log of x squared minus 15 and natural log of x minus 3. If we plug 4 in for x here in natural log of x squared minus 15, I will have 4 squared minus 15, which is 1. That's fine. Plugging 4 in for x in the natural log of x minus 3, I would have the natural log of 4 minus 3, which gives me the natural log of 1. That's fine. X equals -3, however, if we plug in -3 for x, in the natural log of x minus 3, I would be taking the natural log of -6, which is not allowed. So my only solution here is x equals 4. Try on your own. Solve the equation. Log to the base 5 of x squared minus 6 equals log to the base 5 of 5x analytically. We will solve one more equation here. Log to the base 3 of x plus log to the base 3 of x minus 3 equals log to the base 3 of 3 minus x. I notice that the log on the left side of my equation is not isolated. I will use the product rule to write this as log to the base 3 of x times x minus 3. And so now I have isolated logarithms on each side of the equation. And I can use the one-to-one property of logarithms to set x times x minus 3 equal to 3 minus x. So that is x squared minus 3x equals 3 minus x. I'll add x to each side and subtract 3, resulting in x squared minus 2x minus 3 equals 0. We can factor into x minus 3 times x plus 1. And then if I set each of those factors equal to 0, I have x equals 3, x equals -1. We need to check the domain on each of these. Note that if I plug x equals 3 in for x in log to the base 3 of x minus 3, I will be taking the log of 0. That's not allowed. If I plug x equals -1 into log to the base 3 of x, I would be taking the log of a negative number. Not allowed. Here there is no solution.